Good morning, guys! We have here the third method in solving for linear equations. So this method is what we call the Cramer's rule. Okay? So we have here an example. 2x minus y minus z equals 0. 6x minus 7y plus 2z equals 11. And negative 17y plus 8z equals 11. So again, we're going to get the coefficients. So we have 2, 6, and 0. We also have negative 1, negative 7, and 17. We have negative 1, 2, and 8. So let that be our matrix A. And then this becomes our matrix B. Okay, 0, 11, 17. Then we are going to build or create three matrices here. We have A sub 1, A sub 2, and A sub 3. A sub 1 is created when you replace your first row by this one. Okay? Alright, so you replace 260 by 0, 11, 7. So you have here, and then copy the rest. Okay, negative 1, 7, negative 7, 17, negative 1, 2, 8. Now, A sub 2 is created, matrix A sub 2 is created by replacing the middle one by matrix B. Okay, so copy 260, then that becomes 0, 11, 7, then copy negative 1, 2, 8. And finally, A sub 3, matrix A sub 3 is created when you replace the third column by B. So copy 260, negative 1, negative 7, and negative 17, and then write down 0, 11, and 7. So after creating these matrices, you are going to get the determinants. So what we're going to do now is erase this because this is supposed to be, sorry. Okay, this is supposed to be, alright, so since it's determinant, okay, so it's absolute value symbol. Alright, so we have the determinants of A sub 1, A sub 2, and A sub 3. Okay, so let's do the basket weave. Alright, so this is 0 times negative 7 times 8 is 0. Then we have negative 1 times 2 times 7 is negative 14. And then negative 11 times, positive 11 times negative 11 times negative 1 is 187. Then negative 7 times negative 1 is negative 49. 11 times negative 1 times 8 is 88. And 0 times negative 17 times 2 is 0. So we have negative 14 plus 187 minus 49 plus 88 is 202. So that's the determinant of matrix A sub 1. Okay, for matrix A sub 2, so we have 2 times 11 times 8 is 176. 0 times 2 times 0 is 0. Then 6 times 7 times negative 1 is negative 42. 0 times 11 times negative 1 is 0. 6 times 0 times 8 is 0. And 2 times 2 times 7 is negative 28. So we have kindly review your procedure in getting the determinants of a 3 by 3 matrix. So 176 minus 42 minus 28 is 106. And we have the determinant of matrix A sub 3. So 2 times negative 7 times 7 is negative 98. Negative 1 times 11 times 0 is 0. 6 times negative 17 times 0 is 0. So 0 times negative 7 times 0 is 0. 6 times negative 1 times 7 is positive 42. Of course, we're going up, so negative times negative, that's positive 42. I hope you can remember that. 2 times 11 times negative 17 times negative 1 is 374. So negative 98 plus 42 plus 374 is 318, which is now the determinant of matrix A sub 3. Finally, let's find the determinant of matrix A. Okay? So that means our absolute value symbol. So, we have 2 times negative 7 times 8 is negative 112. Negative 1 times 2 times 0 is 0. 6 times negative 17 times negative 1 is 102. 0 times negative 7 times negative 1 is 0. 6 times negative 1 times 8 is 68. Negative 17 times 2 times 2 is 48. So, negative 112 plus 102 plus 68 plus 48 equals 106. So, those are our determinants, and those determinants are very important for the next step. We identify, or we can find the value of x by dividing the determinant of matrix A sub 1 by matrix A. Recall that matrix A sub 1 is 212 divided by 106, that's equal to 2. Then y is equal to the determinant of A sub 2 divided by the determinant of A. A sub 2 is 106 divided by 106, which is equal to 1. Finally, z is equal to the determinant of matrix A sub 3 divided by the determinant of matrix A. Matrix A sub 3 is 318 divided by 106. We have 3. Therefore, x sub 2 is 2, y sub 1, x is equal to 2, y is equal to 1, and z is equal to 3. So that's how we obtain the values of x, y, and z using the Cramer's rule. I hope you have learned a lot in this example. So this is Dr. Batukan saying, mathematics is easy to learn when one learns with enthusiasm. Bye!